Hello, welcome to this video, Camera Focus and Aim, as part of the 3D Gait tutorial series. This video will outline how to set up and optimize your cameras for use with 3D Gait. The recommended 3-camera configuration can be seen here. Note, it is recommended to offset the height of the lower cameras, as this does improve the stability of marker tracking. Cameras can be mounted directly to a wall or on tripods, with wall mounting being the recommended option. Before mounting, it is important to also consider your capture environment. If possible, avoid rooms with bright uncovered windows or rooms with continual traffic directly in front of the treadmill. Bright lights from windows or reflective material on shoes or clothing can affect data quality. Once mounted, your cameras now need to be focused and aimed. To begin, aim the cameras to the center of the treadmill. Next, note the 3 adjustment rings found on the cameras themselves. The one closest to the camera base is the zoom, followed by the aperture, and finally, the focus is found closest to the camera lens. You'll notice some letters marked around the adjustment rings. For the zoom, the W and T refer to wide angle and telephoto respectively. For the aperture, O and C stand for open and closed. Finally, the focus has markings of N for near and infinity. The workflow for focusing the cameras can be seen here, with 5 primary steps and 4 decisions. Given that every environment is unique, there is no one-size-fits-all approach to focusing the cameras. Instead, as you can see, it is an iterative process, requiring small adjustments being made to achieve an optimized focus. The process begins at the upper left-hand corner of the diagram with the initial adjustment of the zoom. It may be helpful to refer back to this diagram as we proceed through the steps. To begin, open Vicon Tracker, highlight a camera, and select Camera View. Next, under Grayscale mode, select All. This will display the raw feed from the cameras with an overlay of the marker tracking. Place a marker shell in the middle of the treadmill and prop it up so it is facing the cameras. Depending on the initial settings on your cameras, you may notice your camera view is completely blank. This is to be expected for an out-of-focus camera. For small rooms, for example where the treadmill is approximately 1 meter away from the wall, slide the zoom adjustment ring 1/3 of the way towards the W. For larger rooms, adjust the slide ring to the halfway point between the W and T. Note, this is just a starting point and this zoom may require optimization. With the initial zoom set, the next step is to open the aperture all the way towards the O. Depending on the amount of light in your environment, we may need to close the aperture later. However, to begin, we start with it all the way open. Next, move through the focus adjustment ring until the markers on the treadmill come into view. It is not important to fine-tune the focus yet. What is important is to be able to see the markers. With the markers visible, we can now check the camera aim. We want the camera to be able to see the markers and any space a marker could occupy with a subject running on the treadmill. Pick up the marker shell and hold it at the back edge of the treadmill. This represents the lower bound of the field of view. Make sure the markers are visible with room to spare. Next, stand in the middle of the treadmill and place the shell on your sacrum. Then, raise it to the height of a hypothetical very tall person. This represents the upper extremity of the required field of view of the cameras. Again, make sure there is room to spare, as during running, a subject will also vertically oscillate during their flight phase. If markers are being cut off, or if, for example, only half the field of view is being occupied by the subject, adjust the zoom accordingly and repeat step 3 as necessary. With the field of view optimized, we can now fine-tune the focus. Place the marker shell back on the treadmill and prop it up to face the cameras. In Tracker, zoom in on the marker shell by holding right-click and moving the mouse upwards. Then, pan to the markers by holding down both right and left click. Now, there are 3 considerations when fine-tuning the focus. the size of the markers, the intensity of the pixels, and the shape formed by the pixels. The goal is to strike a balance between these factors to minimize the markers merging while having them still visible to the cameras. Ideally, the circles should be 2/3 the width of the crosshairs, with limited blinking or gray pixels around the edges. A good focus is striking a balance between these factors, since inevitably one or all of these factors may not be perfect. With the focus set, zoom out in camera view and ensure there are no stray reflections being viewed by the cameras. If there are, close the aperture until they disappear. Then, repeat the fine-tuning procedure to find the optimized focus. Once optimized, repeat steps 1 to 4 for each camera. Make sure to tighten the set screws on the adjustment rings, and return the grayscale mode to auto after you are finished. With the focus and aim optimized for each camera, you can now perform a calibration. Hold the wand flush with the cameras, with the handle facing upwards, and move the wand up and down throughout the volume of the treadmill. The progress bars for each camera should update at approximately the same rate. If one camera is lagging significantly behind, there's likely an issue with your focus or aim. If this is the case, in Tracker, open camera view to assess the situation and then make the appropriate adjustments to the camera settings to resolve the issue. After successfully calibrating, you will then need to set the origin. Place the calibration mat in the center of the treadmill and align it with the treadmill belt. Once completed, zoom in on the wand markers in a 3D workspace and ensure they are visible and not jittering. If they are stable, your system is ready to collect data. Even though your camera settings are optimized, it may be necessary in certain circumstances to make software setting adjustments from time to time. There are 3 primary settings of interest. Intensity refers to the intensity of infrared light coming out from the cameras. Lowering the intensity will result in the markers being less visible to the cameras. The threshold refers to how bright a reflection off a surface needs to be for Tracker to assign it a pixel. Lowering the threshold will make the markers and everything else more visible to the cameras. The minimum circularity ratio refers to how circular a blob of pixels needs to be for the system to track it as a marker. Set this to approximately 1/3, as this will function best with the size of markers used for 3D Gait. Small adjustments to the intensity, threshold, or minimum circularity ratio can be made to improve marker tracking, especially for markers such as the trochanters, which can become occluded by clothing. However, if large-scale adjustments are required to these settings to achieve adequate tracking, it is likely that modifying the hardware settings, the zoom, aperture, and focus, is required. Note, there is always a trade-off when modifying these settings. Making the markers appear bigger by increasing the intensity or lowering the threshold can result in an increased chance of markers merging, whereas making them smaller will result in an increased chance of markers being dropped entirely. And that concludes this tutorial video on camera aim and focus. Thank you for watching.